Now I invite Angelo Pereira, our Vice President, to address you all.
All right. Thank you so much, Rico, for that. Hope you guys are doing great, and it feels so great to have you all back with Eric KDU once again for our second session of IoT series. So in the previous session, we talked about, we gave a brief introduction about what IoT is exactly. And also our president will explain to you about the ESP32 and the ESP8266 microcontrollers. And my friend Navoda gave you a brief introduction about the basic applications such as the Arduino Cloud. And also I remember we turned on and off an LED using the web page. So all these lovely things happened in our previous session. So if you guys missed our previous session, so there's nothing for you guys to worry about. You just have to go to our YouTube page and we have the recording there, and the links will be shared throughout the session. So please do remain with us throughout the session. And also I know with the increment of the COVID situation back here in KDU, many of your friends are going to be a bit late to join, so please pass the message to your friends, because today it's going to be a really important session for you guys, because we have a very resourceful person with us. So don't let your friends miss this great opportunity. Ask everyone to join as soon as possible, and hope you guys will learn a lot and have a great session today. Rico?
Thank you, Angelo. Today we have a very special person to enlighten us with his knowledge and experiences in the field of IoT. Ladies and gentlemen, please welcome Supal Edarasinga on Spotlight.
So thank you, Rico, for this lovely introduction. So I believe I'm audible.
Yes, you're loud and clear.
Yes, Sajay, you can continue.
All right. Okay. Let me share my screen so you can confirm whether I'm visible or not. So I believe the screen is visible.
Yes, we can see the screen.
And there's no lag, right? You can hear me loud and clear.
Yeah, you're crystal clear. You can proceed.
Sure. So good evening to every one of you. So I'm Supal Edarasinga. So I believe in the earlier sessions, you guys have learned a lot of things about IoT, what is the Internet of Things and how to use those things. So first of all, I will give a brief recall on what IoT is, what is Internet of Things, and why do we use them. So basically, so we know what the Internet is. Internet is a collection of we say computers, because we say there are websites and there are services, but basically everything in the internet works inside a computer, right? So basically a server is a really big computer. So that is that is the internet. So we don't call it the internet of computers, but that is what basically it is. We can call we have our mobile phones which connects to the internet, and also our computers, and maybe our smartphone, smartwatches, and also the IoT devices. So internet is made up of computers. So we just call them internet without calling them internet of computers. But then what happened is we discovered microcontrollers, and we discovered that we can we say that we can interact with microcontrollers over the internet. We can make a sensor, put it in a somewhere, like let's say we want to measure our temperature of a roof, right? So we will design a little circuit and put a sensor on it, and we will put it on a roof. So how do we get those readings? We can either use the basic method using a wire, or we can use the internet or our mobile signals to communicate with our devices, right? So the sensor connects to the internet, and over the internet we can get our data, like readings. So let's say those are internet of sensors, right? But in IoT, we don't only have sensors. We have I think there was a very good demonstration of turning on and off a light in the last session. So we can turn on and off our lights, maybe dim our lights, maybe control a security system. So that is just internet of a lot of things, right? So that is why we call this internet of things, right? Okay, so I believe you have seen this this thing, right? A cloud. We always refer to the internet as a cloud, right? I believe it comes in the later slides, but the cloud, we all have heard about the term cloud, right? The cloud is just a collection of computers. It basically is the internet, right? So the internet is made up of. So now there are many things. Maybe our smartphones, our smart watches, our smart homes, security systems. We all know. We know now we have smart security systems also. I think we all have heard about IP cameras. When it comes to the surveillance, everyone like the most, I think, most famous brand is Equation, I think. So they all have the internet monitoring systems. So those are all IoT devices. Okay, so it is the Internet of Things. All right. So we saw how to use the IoT devices or the internet, and now this is a very common term we've heard. Whenever you browse the internet, we get cloud computing, and the next word is IoT. We all get those two words almost every day. At least once a day, we encounter those things, right? So what is cloud? I said earlier, the cloud is basically the internet. It's made up of maybe 10, maybe 1,000, maybe millions of computers. So it is in the internet, and we are always referring to the internet as a cloud, right? This has been the standard since whenever the internet was born, like the early 90s and 80s. So we call it simply the cloud, right? So basically cloud computing and IoT. So that means IoT devices connecting to the cloud. Okay. So this is I think I took it from from the internet. So this is a very good illustration of how IoT works. Right? We have our monitoring services like computers, like tablets, smartwatches, and we have our sensors. Okay, let me get my pointer. Okay, we have our sensors and all the IoT devices in the left. So that that may be like something like a thermometer, or maybe like a smart home. Okay, smart home with all those automatic check controls and automatic light controlling, security system, alarms, everything. And maybe it's in a very large scale. Okay, maybe it's a smart city, like all the traffic light systems and everything working, or the internet connected to IoT. So maybe that's that. So everything we can see here, those signal icons. That means there's a connection. Okay, we have our devices, so we have a way to connect to the internet. So there's that, and we have our cloud. We have maybe we have a server of our own. Maybe we are just using as API provided by some big company like Google or Amazon or maybe Azure. So that's the cloud, IoT cloud platform. So I believe in the last session you guys have used I believe that's called ThinkSpark. So that is a very good cloud platform. We can use that cloud platform to very easily connect with our IoT devices without doing any configurations almost. And we can we have our monitoring systems, right? This is our client side. This is our sensors, and this is our server. Okay, those are the basic things in the IoT, right? Our client usually monitors and give orders to our IoT devices. So that is like the administrator. Okay, so when we use those things like cloud computing, let me, it's my whiteboard. I believe that's, you can see the screen, right?
Yes, can see.
Okay, so music. So let's say we have a sensor. Okay, we have some kind of a sensor, maybe a thermometer. Let's say it's a thermometer, and we are using a mobile signal, something like 4G, to connect to a cloud. Okay, there's our cloud, and we have a computer monitoring the situation. Okay, so we have just a one sensor, so it's a no-brainer, right? It sends signals like what's my temperature now, what's my temperature now, like let's say once every second. It tells the server what is my status. Now it's 24 Celsius, in a second now it's 24.1, so on. Okay, so this is a very simple scenario. So the server usually reads those data and processes. It makes, we say we have data and we have information, right? So information is processed data. So the data is just unprocessed something. Maybe it's, in this case, it's temperature, right? So the server processes it and outputs to our monitoring system. So it can either graph what is the temperature difference, or maybe it can view what is it right now on a mobile phone, anything. So this is the simple situation. Okay, so now let's make this very big. Like let's say we have like 1,000 of them. For some reason we need 1,000 sensors. So let's say this is a agriculture farm. Okay, this is a farm. This is a huge, maybe multiple acres farm. So these sensors measure temperatures of each crop, maybe in each sites. It is measuring what is the temperature now, what's the humidity now, and maybe there are some soil monitoring sensors. which monitor what is the humidity of this soil, what are the minerals, what are the percentages of those minerals. So that kind of thing. Okay, so this is a huge operation. Okay, so now every single second there are at least 1,000 requests to the cloud, right? So let's say this is a 1 kilobyte. Okay, one single let's say one single request is, one single update is 1 kilobyte. 1 kilobyte, we know that's very neglectable. It's a very small size of, okay, but when it comes to 1,000 sensors, that is 1 megabyte, right? 1 megabyte. Now we see the problem. Every single second, this system uploads 1 megabytes of data to the cloud, right? So we need at least this bandwidth, right? This is we know our conversions. 1 megabytes per second is equals to 8 megabits per second in bandwidth, right? I believe those things are familiar with you. Bytes and bits. 1 byte is 8 bits, and we always refer to transfer speeds in bits, megabits, kilobits. We can see in almost every advertisement, we can get unlimited 1 Mbps connection, and when we get it, we only get like 200, 300 kilobytes per second, right? That is 1 Mbps. So when we need to upload like 1 megabytes of data, we need 8 megabits of data bandwidth. Okay, so we see the problem. Every second, these things transfers to the cloud, 1,000 of 1 kilobyte messages. Okay, and again, this cloud might get overwhelmed if we have more than one farm, right? One farm has a system that sends 1,000 of them. We have 3,003 farms. We have 3,000 things coming at this cloud at once. So we know we need to make this quite large. We need to expand this to manage all those things without delays. All right. So first thing, our upload bandwidth might be limited. Okay, and also we are uploading so many data to the cloud just so we can monitor them. Okay, so this is a problem, right? The problem in sense, first we need to take care of our internet bandwidth, so we are paying for that. We need to worry about those things. And secondly, we just don't want to, let's say on the first second the temperature is 24 Celsius. In the second it is also, there is no some drastic differences in temperature, right? Temperature wouldn't change for like 10, 20, 30 minutes. That's the, unless it's like a very unnatural situation, these things wouldn't change, right? I believe you guys can understand this. So for something period of time, this will stay static, and this is the case for almost every scenario in IoT when we occupy a huge number of things, right? Most of the things will stay the same unless a changes occur. So we need to we can see that if we give some value to the cloud at the beginning, and if we can give only those values, update those values when only it changes, we can see that we can drastically reduce those things, right? Or maybe we can process this on site, right? We can put a computer here and we can collect all those 1,000 samples to our local computer, and we can process those things here, right? And we can only send the differences or what's really important to the cloud and update it there, right? So this will be like 100 kilobytes per minute, right? Because we don't need to update this cloud every 1 second. So let's say, let's change this whole, let's take a very timely subject. So let's say this is a COVID ward. Okay, we have like this, and every single is what those are. We need those things. We needed those things in COVID to overcome, to check whether we have pneumonia or our blood level oxygen is falling. So let's say this is such 100 patients. Okay, 100 patients. So we have a cloud, and it might be limited in the processing power also. So every data that's been read here is sent to our cloud, right? Like every data that's been read is sent to our cloud, like every 1 second. Let's say this is really overwhelmed. This cloud service limited, and also we have to calculate the, let's say this service in Malaysia. Okay, let's take the Malaysia or Singapore. Okay, let's take Singapore. Let's take Singapore, this Singapore, right? So let's say, for the sake, this for one request to reach the real server, it takes about 100 milliseconds. 100 milliseconds, and this takes about 1 second to process all those details and check whether anyone is reaching a critical level or anyone is in need of medical assistance or something. Okay, it takes about 1 second, and again 100 milliseconds to reach this. Okay, so we can see that we need at least 2 seconds. There's at least 2 seconds delay between only to transfer those data, right? So if we are thinking about something like let's say monitoring system, there's the possibility is our bandwidth isn't stable. All right, so this 1 second, 2 second delay can in times can up to like 1 minute, 2 minute delays. Okay, so as only showed 1 second. So let's say our mobile data signal are very bad. There's raining or something happens, and this transfer gets interrupted. So we might have longer periods of delays. So that is very critical, right? That is very critical. It takes about a minute to show the results in the monitoring system. So once you get the monitoring system, that's only when the health authorities can take action, right? So there's a delay. There's always a delay, but cloud computing might just extend it. All right, so this might be critical. I believe you can see the timing problem and the bandwidth problem. So to overcome that, the solution, the network architects and software engineers in IoT have come up with this edge computing. All right, so the edge computing is a distributed IT architecture in which the client data is processed at blah blah blah. And I will tell this in layman's terms. The thing is, let me draw this thing again. real quick. We have our IoT devices, our monitoring system. So instead of connecting to the cloud directly, let's add another layer. Okay, let's add a local computer and a local database, and we call these edges. Let's call these edges. What those edges do, it will process those things quickly, and it will provide feedback very fast, very quickly. All right, and it will process all those data inside, on site. Okay, really close to those IoT devices, physically close, I mean. Okay, so otherwise the cloud would be like thousands of miles away. Okay, physically close to our sensors, and data will be processed here up to a point. All right, we have a storage server here. Let's say this is a storage server. Okay, so the data will be stored here, and let's take the first thing. What's that? Our temperature measuring thing, agriculture scenario. So every data will be stored on a local database, and it will be processed, and the server will only transfer to the cloud the necessary information. By necessary means, if there's a difference in this temperature, it will only transfer them. Otherwise, it will say, I don't have any updates right now. Okay, so keep updating the records with already existing results, right? Repeat those things. Let's say the first sensor recorded a change. So it will only say the first sensor noticed a difference in the temperature. The new temperature is this. Okay, so we can see instead of sending 1,000 requests, we can send like 1 or 2 requests. This is edge computing. Okay, that's what this description means. Okay, it's a distributed IT architecture, which means we say this is centralized architecture. Okay, so for every sensor we have one cloud, so one cloud for everything. So this is centralized. Okay, so we call this distributed. Why? We can there are more than one edges connected into each set of sensors, and it will process everything on site. We call those edge nodes. Okay, so that's why this is called edge computing, because of the terminology, because we chose to call these edges. We chose to call those local servers edges. Okay, so that is what the edge computing means. Basically, we are adding another computer between our cloud and our sensors. So that also reduces all those latencies, right? If there is some measures to be taken, they will be taken much fast, right? We don't have to rely on our internet to update those monitors. We can directly update those monitors using our edge nodes, right? So we can reduce our response times in those like those very critical situations to from minutes to seconds constant, right? It won't take longer than 1 or 2 seconds period, because we don't have to rely on our internet to receive any more updates. Okay, we are receiving updates. Just to be clear, we will be receiving updates from the cloud, but we will also be receiving those things from our edge nodes. So yes, that, and that actually reduces a lot of things. Okay, so that's edge computing. So just a terminology, we don't have to actually develop those things. We already have. So this is a very different time, right? When I was learning these things, I had to, if I want to make a edge node, I have to build a physical computer, install all those things, and set up all those things. Now we just have to download a software that manages the edge computers and install it and give our credentials, and we are good to go. Okay, same thing with cloud, same thing with all those sensors and operating systems, everything. Okay, we are in a very good time. Okay, so in last sessions, you guys have seen how IoT works and how to spin off a web page using just an Arduino, maybe an Node MCU, and use that website to send a signal over the internet to our bulb and turn it on and off, or maybe we can scale that up to a house. Okay, we can use smart control house. We can make a DIY smart home, right? Okay, so today we'll let's dive into let's just dissect what happened there, right? So I'm going to break this up to four sections, right? First one is how to connect. Okay, how to connect with IoT devices, how the IoT devices connect to each other, how they connect to the cloud. Okay, that will be the first part. So the second part will be once they are connected, how do they communicate, right? We know we are human and we have our languages. So when two people meet or when they take a call, we usually speak, right? We speak with our words, we speak with our language, and we communicate. So those are not human, but we treat them as human, right? We give them power to use the internet, so why not talk with them, right? So we need a communication method. So that will be the second part. And third one will be we are human, they are machines. How can we see what they are doing, and how can anyone see what they are doing, and how can a not programmer, right, like a normal person, see what they are doing and change what their behaviors and give them orders, right? That's the UI part. And then there's always the elephant in the room. If these are very easy to implement, if these are very we can just within clicks of our buttons we can do everything. So how secure are they, right? We know in our computers, whenever we install a new operating system, whenever we buy a new computer, first thing we ask is, do we have antivirus? Do we need an antivirus, right? We know when we are in the internet, it's not a safe place. We have to be aware about that, and we need to take security to our own hands, right? Okay, so where do we stand with security with IoT? So that will be my last part. So let's go. Okay, so how do IoT devices connect to the internet? Just a reminder, if anyone doesn't understand what I'm saying, or if I'm too fast or need any clarification, please don't hesitate. This is not a lecture. Okay, you guys can converse with me. You guys can send a message, unmute yourself and speak with me, anything. All right. So I actually really like if someone like me would ask some questions or something, right? So I know you guys understood what I'm saying. Okay. However, connect. How do they connect? So whenever we talk about this, this is like the only three things we get into our minds, right? Wi-Fi, Bluetooth, or maybe GSM, like cellular data. So actually, these are the main three things in IoT. Okay, our IoT device can either connect to the Wi-Fi network or the Wi-Fi to the internet. Okay, so maybe we are using something like a SIM card or a CDMA connection, so we can use cellular networks, right? Like our mobile phones, we can use cellular signal to communicate with our servers, cloud, other sensors over the cellular. And the last thing is Bluetooth. Whenever we see Bluetooth, I believe you have heard those two terms. First one is Bluetooth, I say BLE, Bluetooth Low Energy, right? Bluetooth LE. So whenever you buy a smartphone, just make sure to check in the next time. There's always the Bluetooth Low Energy mode, right? This is a very low powered communication protocol listed on the Bluetooth. These two are not the same. These two are in the same family, but not the same. We have our good old Bluetooth. We call them BT or BT serial. So we have two methods of communicating when we are using the Bluetooth. So I just said these are not the same because if you are using an Arduino, if you are using an ODMCU, maybe a Raspberry Pi, whatever. Okay, whenever you are using an IoT device, these two things are really different to implement. Okay, so if we are using a Bluetooth module like let's say ESP, okay, usually ESPs have Bluetooth serial. Okay, usually it is only supported BT, not BLE. Okay, so this is a very different protocol to program, and this is a very different protocol to program. These things work very different internally because this is a very low energy thing. This is like, this actually consumes power very close to Wi-Fi. Okay, I'm not lying. You can search it up. The normal Bluetooth uses about the same energy as Wi-Fi in current situation. Okay, because the Wi-Fi has gotten really good at power saving, and Bluetooth has gotten really good at power saving in low energy mode, not BT serial. Okay, so we know our cellulars, okay, 4G, 3G, and upcoming 5G. Those things are used in cellular IoT. Yes. So now, first thing is, more than we think this is the main method in IoT. All right. The reason is, let's say our IoT means we are actually using something like a farm or a maybe a really big assembly line, automated something. We will be using cellular in most cases, like 80% of the time we will be using cellular data. Why? One thing is, let's say we are using a Wi-Fi. Okay, when we are using Wi-Fi, we need a router, right? A router can usually multiple sensors will connect to the single router, right? Because it's not practical to have, like, if we have 1,000 sensors, we don't have the it's actually not practical to have 1,000 routers to manage those things, right? So this is we call this this is a weak link, right? If this router fails, all the sensors actually slave to this or connected to this will lose their way to communicate with the cloud, right? To the connect to the cloud. Yes. So same with the Bluetooth. Bluetooth is not a way to connect to the internet, right? We all know that Bluetooth is a way to connect to another device, like a smartphone or something. Let's say we are connected to a smartphone with Bluetooth. Okay, So we have some monitoring device, let's say a pulse oximeter. Okay, this is COVID times, so we have a pulse oximeter that's we are wearing on our finger, and we have a smartphone, and we have an app on it that monitors our blood oxygen levels remotely. All right, so the Bluetooth only connects to the smartphone. Smartphone connects our devices to cloud. Okay, Bluetooth is just a intermediate. Okay, so we know that Bluetooth also needs to connect to something in the middle, and whenever that fails, this device loses its ability to communicate with the cloud or connect to the internet, receive anything, send anything. Okay, but when it comes to the cellular, we don't actually manage our cellular towers, right? They are built from our ISPs, our internet service providers, our network service providers. Those are the persons who build those things, right? We are just connecting to it, and we know if we are living in an urban area, a single cell tower may be connected to thousand, at least 1,000 devices, right? So cellular IoT is very reliable when it is not without any pitfalls. Okay, so we saw those points of failures. This is a single point of failure, this is a single point of failure, and our tower is the single point of failure, right? So whenever those sensors are connected to our tower, we know there is actually less chance of failure than these things. Okay, but there's a big but, that is if we have like direct contact or strong bandwidth with the cell tower. Okay, if the cellular signal is low or very weak, it doesn't have a lot of bandwidth, then this is a very bad decision for us. Okay, this is at that moment this becomes not feasible. We have to settle for another method. Okay, so that's why cellular is really focused and targeted. And there's this, you all have heard about 2G, 3G, 4G, and 5G, right? Those are the generations of mobile signals. All right, so we know 4G also is known as long-term LTE. Okay, so LTE has a different this part, LTE-M. Okay, it's a sub service of LTE, which actually focuses on IoT. All right, you can search this up. Just go to Google and type LTE-M. You will see this is the protocol that's used to actually used only in IoT. So this is a band that's dedicated for IoT in 4G. So LTE-M, and I think if you are in tune with the tech news and or blogs or maybe YouTubers, 5G, that's a really big deal. That's a huge deal in IoT. Why? So we know, we actually even I didn't understand why it's a really big deal in IoT at first. So we know with every generation, in every mobile generation, okay, let's say let me go back and go to the sketchboard. Okay, so we are familiar with 3G. Okay, and we have 4G. We also call this LTE. Okay, now we are still in the phase of checking whether it's feasible in Sri Lanka, but we have nevertheless 5G. Okay, we know if we compare internet speeds with, okay, let's take another one that we know very well, 2G. Okay, so if I am to compare something with those three things, first thing we are going to say is this is really fast, right? This is really fast, and this has I know most of you guys know this word, even though you are not well versed with tech. Ping. All right, what is ping? Actually, ping, or I will call this latency. Latency. Okay. So what is ping? Ping is the time that takes to some signal to reach from one place to another, like our smartphone to our gaming server. Okay. So that is basically how fast our uh, line is. Okay. So we know uh, when we consider latency, 4G has the lowest latency or the fastest response times. Okay. So it is not really surprised that 5G must have the lowest latency of all those things, right? And speed of the bandwidth. I will call this bandwidth. I will call this bandwidth. That's the same thing as the speed. Okay. So far, 4G has the highest bandwidth. Okay, we can like transfer hundreds of megabytes whenever the signal or our connection is strong. Theoretically, we can transfer up to 1 gigabyte. Okay, so hundreds of megabits, not a problem. So gigabyte 5G, that's on another level. Okay, so 2G has the slowest. I think it only operates in kilobytes range, like 100 kilobytes. This works like for a few megabytes, right? Like we can get up to 2-3 megabytes, and this is a beast. So this will be a beast, like, right? We will reach gigabytes of bandwidth without any problem, right? Like, okay, so 5G and IoT. So 5G actually has a dedicated part like LTM built into 5G because LTM actually came after the 4G was introduced. Because even though I think IoT is older than all of us, okay, it actually came to life in 1999, I think. So it was a proof of concept much more earlier. So IoT is not a very new thing, but it has gotten attention in really recently. Okay, so technology is advancing as it is going. So 5G has a really good grasp on this. Okay, so now let me ask you something. So I have this device. Okay, I have this device. Let's say it's like a watch. Okay, it says those. It's a wearable. This is a wearable device. Let's say this is a smart health tracker. This is a health tracker. I can wear it on my hand, and what will this will do is this will read my data. Okay, this will read my temperature and my heart rate, as I will call that BPM, and my SpO2 levels, that is my blood oxygen levels, and What else? Okay, let's say those three things. It is measuring those three things, and it will be transferring all those things to my mobile phone. Okay, it has app and everything, and also there's a cloud and all the ecosystem is there. Okay, so my problem is this is a wearable, right? And it will be communicating with my mobile phone with let's say Bluetooth LE, BLE. So if I have to worry about something, what is the most critical thing that I have to think about when I'm designing this fitness tracker? What might be the most critical thing other than my accuracy in sensors? Other than the accuracy in sensors, what might be the most critical thing I have to take into account when I'm designing this? I expect some answers. Can someone, like, you could be wrong, you could be right. This is not exam, right? Can someone at least put what you think in the chat? Sorry. Anyone? What I'm asking is, if I am to consider something like maybe it's the how long my range should be, or maybe anything. So what might be the most important thing in my design that I need to consider? Okay, so okay, I'll give you all right. So I'm getting answers like the sensor readings. Okay, okay, okay. I think it might be a bit difficult. Yes, yes, you're right. That is actually the most important thing. Battery power. We are powering this with some power source, right? I have to at least use this from dawn to dusk, right? Because otherwise there's no point of using this. And one thing is how long I should use this. So everything in this should be low powered. But while it's being low powered, I have to communicate with my smartphone for reasonable distance, like let's say 10 meters, because I might leave my smartphone at my desk and maybe go to fetch some water, maybe something. So the connection should stay there, stay connected, right? Those two things should stay connected. And this is the case for almost every IoT device that is not directly connected to the power. We need to take care of our power needs. Okay, so now we know that using a GSM module is not ideal for every situation. Maybe Wi-Fi, maybe we have to use, we have to use BLE because of our power. Okay, because we know cellular actually cost us power. Okay, so we actually have a very innovative idea. I think you guys might have heard this in last sessions also. LoRaWAN or LoRa. Okay, you guys might have heard this as LoRaWAN, like with WAN after this. So okay, LoRa or long range. Okay, LoRa means long range. It's just a fancy word to call this protocol. This is actually, I think, if anyone is interested, please take a note. Go to the internet and browse this. This is a very innovative method of communication. Okay, it's not cellular, it's not Wi-Fi, it's not Bluetooth. It's not anything I've discussed before. It's a wireless communication method, and it is really low power. Okay, so we can communicate like meters, maybe kilometers, with just a sip of energy with this technology. Okay, the receiver has to be high powered to receive those signals, but nevertheless, we can very reliably use LoRa technology to send some signals to a far away distance with very reliable, very low power and really high accuracy. Okay, so I believe you have seen those first two. What these are? First one is a Node MCU. Okay, it's a Node MCU. It has Wi-Fi built in, and whenever you see this kind of shield, it's usually in a microcontroller or MCU. It is usually a Wi-Fi or GSM module. Okay, this shield, that's what this is used for. Okay, so this is an Node MCU. I believe this was the device that's used to demonstrate in the last sessions. Okay, this is a this is a SIM card holder. This is a GSM module. We can attach this to a Raspberry Pi and Arduino, anything. So this will make a connection from our sensor, from our Arduino to a cellular tower. Okay, so the final one is, this is a LoRa module. So it's a really small thing, but I think this has like few kilometers of range. Okay, this is a really small device. This actually sips energy. Okay, this doesn't drain our batteries fast enough. It's something interested parties can actually see. Okay, okay, so we have discussed how a sensor, basically a sensor. So let's see how far we are. Okay, you can't see my screen. Let me check that. Is it visible now? Yes, okay, amazing. So we have our sensors, and we have maybe our Arduino, maybe our Raspberry, maybe our Node MCU, anything. That's a microcontroller. A microcontroller that's paired with our sensor, and we have a method of communication. Okay, we have a cloud, and this is the internet, and we have a method to connect to the internet. Okay, so that's the first step. Okay, so communicate. How do they talk? So the presentation is also visible, right? Yes. So we have our languages, right? We humans have our languages, okay? And we have a language to program our devices as well, right? And So there's no brainer that there exists some method to communicate between two sensors, right? Maybe a sensor and a computer, maybe sensor and the cloud, maybe a IoT device and the cloud, anything. There must be a method to communicate through the internet using some kind of a protocol. Okay, we call those things protocols. The methods, means of communications, we call them protocols, right? Because the internet is like a highway. Okay, how we are going to travel in this highway totally depends on us. Okay, so just like vehicles, we have our protocols. So these are a very okay, MQTT, okay, MQ telemetry transport. This is the celebrity right now. Okay, this one is the like the most this one is the most famous one right now, MQTT. Okay, MQ telemetry transport, or we call those MQ message queue telemetry transport. Okay, so that's the biggest guy in the scene right now in IoT. Okay, other things are HTTP. Okay, HTTP is basically what we are using to browse our internet, hypertext transfer protocol. Okay, that's what we use to browse the internet. So we can use that, even that, to communicate with the cloud, because cloud is in the internet, cloud is a computer, and maybe it's a web page, maybe it's a web service. So we can use our de facto protocol. Okay, so another one is COAP. So COAP or COAP, Constant Application Protocol, and this is not true. Okay. Not you are a media, not a protocol. Okay, not Wi-Fi, but WebSocket. Okay, WebSocket is a it's a new thing, not actual new, but newer than these guys. WebSocket. Okay, so it's a technology that we can use to communicate with those things. So I will just go really lightly on those things, but let's just see what this high HTTP and MQTT is. Okay, because we have used those things in the past. We are going to use those things in the past if we are using IoT. And what damage does do, right? I believe most of you are like computer science majoring or engineers, so I'm not going to go into like really in depth, but I'm just going to say what they are doing. Okay, so HTTP is how websites work. Okay, so if I'm working on this website, let's say I will go to the google.com, right? Google.lk. So whenever I type this and press enter, this will send the HTTP request to Google's website. Okay, HTTP request. It will ask for google.com page in the server, and it will send me the web page. So we call this initial thing where we request a web page get. Okay, there are some things we call this get, and if we are, let's say we are using an IoT device. Okay, we are using an IoT device, and we have IoT device that is using the HTTP protocol. Okay, just like in that case with the website. Okay, last session I saw you guys do the control bulb from the website, right? So in the website, it will, there's the website. So there's the switch. So this is the light. Okay. So whenever we click this switch, it will send a HTTP request to a server, and through that to our IoT device, and HTTP request. So that's how that works. Okay. So we don't have to learn about how HTTP requests work or anything. I'm just saying it worked like that. And let's say we have device here, and we have a monitoring device here. Okay. So, and here's the cloud. I will cut out the middleman. So it is communicating like this. Maybe it's receiving some commands from the cloud, and it will also be communicating this way. Okay. So if I click on this computer, get this, get details for this IoT device, click. Okay. Whenever I click this, it will send a request to get my details. Okay. So we call this get. It is a get request. It is asking to get something. Okay. Just the same. If this IoT device is asking for something in the cloud, it has to send a get request. We call those get requests. We just call them get. Okay. And let's say this device is sending something. This device is updating some data. Okay. Maybe the latest readings of those sensors. So we call this, let's say, we don't have those things. We are sending some details to a friend or the mail. What do we call that? We are posting, right? We are posting a letter, right? Same thing. Whenever an IoT device sends something over the HTTP, we say it is using post. Okay, it's just a word, and whenever we send a get request, it is implied that the server responds with the information that they have asked. Okay. All right. So that's why the computer, we click on this IoT device. We need to see those things, right? So that's why it is get. Whenever we ask to get something, we usually get that. Whenever we post something, it means we are sending some data to the cloud. Okay. So whenever you are using to build an IoT device, and you might have to, you are going to have to, if you are using HTTP, you will have to decide whether to use a get, to use a post, because whenever you search something in the internet, like let's say IoT HTTP requests. Okay. Everything that comes up here, get and post. Okay. So if we know what get is, so we know I need to get this, so I'm sending a get request. All right. So okay. So it's a terminology like you might learn in the future, but you don't need to learn all those things. Okay. Just know the get and post. Okay. There are two HTTP request modes. One is get, and the other one is post. So we use get to get something from a source or cloud or server, and post, create or update something in the cloud. Okay. So another thing we might have heard is TCP/IP. Okay. This is the, like, the HTTP actually works on top of TCP/IP. Okay. TCP/IP is the base of our internet. So if we are using IoT, chances of getting us seeing us these two terms TCP/IP are almost one. Like it will happen, it will definitely happen. Okay, so TCP/IP stands for telecommunication protocol, internet protocol. Okay, IP means internet protocol. So this is I think if someone knows about networking, this is the three-way handshake. Okay, so whenever there's a TCP/IP connection, there's this message that's passed through. So let's say our IoT device is the client. Okay, server is the server. So whenever we need to get something from the server, this TCP connection usually talks with the server and checks whether it's available. So just usually just sending something and asking, hey, are you there? So that's the sync SIN. So the server will say, yes, I'm here. That's the acknowledge. In we say that sync acknowledgement. Usually now we know the server is up and running, right? But no, TCP has to go another step and again say, okay, I got you. So this is, we call this a handshake, and just ignore the terminology, TCP/IP. Okay, so my point is TCP/IP, usually we use this TCP/IP to ensure reliable connection. Okay, so because we need to know we are connecting to our server, we have to have a method to know, to understand, to confirm the server is up and running and service ready to receive, and we have a connection between those two. So that is why we need this SYNAC, okay, three-way handshake. Because if we are using TCP/IP protocol, we don't have to worry about anything at all, because the protocol itself will tell us the connection is not stable, or the connection is breaking up, or you are not connected. It will give us that really. So okay, so yes, I just wanted to showcase this. This is called the Postman. We use this to create some get request, post request, and send it to a server. Okay, so this is a server I have created to for some IoT project of mine. I will showcase this very soon enough. So okay, TCP/IP. So we don't have to implement actually those things. Those things come with the internet. Okay. Main thing is MQTT, MQ telemetry transport. Okay, this is so let's just think we are sending an text message to our friend. Okay, so let's think about that thing. Okay, we are sending a text. We are sending a text message. Okay, because everything aside, the TCP/IP and this HTTP requests are kind of a bit mess. Okay, because these things must have those keys, values, and headers, maybe body, something like this. So it is a little bit messy for a starter to understand, or maybe for even a expert to actually debug. Okay, but if we are thinking about text, okay, so I can tell my friend, okay, I'm talking about this subject, okay, homework. Okay, I will tell him this is about the homework. Okay, subject is homework. Okay, so let's ask him, hey, have you finished that homework, something. Okay, so this is how we send an email actually, right? Not a text message. We don't use subjects. We usually talk them with text, right? Okay, so just think about this. We are sending a text message and we are sending it to a friend, and it is easy to understand, and we don't have to worry about let me show you a HTML request one, HTTP requests. Okay, now let me show you a real one. All right, to see how messy that is. Given all this, it's the HTTP request is kind of advanced in this case because Google is advanced web page and everything. Nevertheless, it looks like this. Okay, it is a really big chunk of data. All right, every single one is really big, and it has all those parameters that we don't know. All right, and status code, request method, this we know. All right, request method is get, and we are requesting from this website. Given all that, but it is messy. All right, it has a date, expire date, modification, CRSS, everything. We don't need that, and it is really messy, and it's a really huge load for anyone to learn just to turn on our lights, right? So, but in comparison, this is like the cakewalk, right? We are using a text, we are just sending to our friend, to whom. All right, so this is basically what the MQTT is. So MQTT has a subject, or yes, subject, let's call that subject, and a message. What is the message? Maybe we call this temp is this. We usually use the JSON notation in IoT. That is, we wrap them in curly braces, and we use those things like this is the data that I'm sending, right? I'm sending the temp, and this is the value of my temp. We are using a colon in the middle. Okay, so this is my message. Okay, subject is I'm sending this to I'm going to say my server. This is what I've named my server. All right, my server, and this thing. It's a given HTML request. This is like reading the alphabet, right? Give a subject and send our message. All right, that is what basically MQTT is. Okay, and from what we have seen, so we know every single character counts when you are sending something over the internet, right? Longer the text is, larger the package is. All right, so we saw that HTML request is really big. All right, so, but in comparison, this is like if the HTML request is like a cat or dog, this is like a fly. Okay, so it is really lightweight, simple. Okay, I will get into this point later. Publisher transcribe model, and it's easy to implement and use, right? Even a program can read it faster than it can read a HTML request, right? It's easier to use, easy to implement, it's fast, it's everything that's not HTML is not. All right. So the idea is this, right? So we have our IoT device. We already know this. We have our IoT device, and that will be sending something. And we have our cloud. We have our cloud that is always waiting to receive something. Okay. So what we are doing is we are putting something in the middle, and we are calling this Mqtt Broker or Mosquito. Okay, Mosquito is a very famous Mosquito. Mosquito is a very famous MQTT client. We can use this library in almost any language. Okay, if you are using Arduino, there's a library for that. If you are using Python, there's a library for that. If you are using Java, you know the answer. Okay, any language, there's a library for that, and it is really easy to use. We don't have to implement anything. We don't even have to code. Okay, we just have to say what the message is and who is receiving it. Okay, so we call this MQTT broker. Why? Okay, so the IoT device is basically sending this message to the broker. Okay, and if there's another IoT device, it will just send the message to the broker, and the broker is like the postman. Okay, so if we are thinking about our classic mail, okay, handwritten letters, mails, we know the role of our mailman. Okay, postman. He has to collect everything, sort everything, and send it to respective parties. Okay, so that's the idea. We can send all those messages into the MQTT broker. Okay, so what we are doing is we are publishing something, right? So we call this publisher. Okay, each one that's sending a message is a publisher. All right. Okay, so these are publishers. So I believe this part is clear now. All right, and you know what the broker is? He's basically the mailman. Okay, so what happens from this side? Oh, okay, so I will add a little bit of things to this one. Okay, we have my server. I will tell okay, you have to go. Okay, my server, and I will tell I'm sending this to my server, and this is regarding temp at home. Okay, simple, elegant, and anyone can understand. Okay, so this is basically that. Okay, we are sending this to my server, and anyone in the my server that needs to know the temp at home. Okay, so here's the thing. You know what the word subscribe means, right? Subscribe basically means I need to know about those updates. So whenever there is one, send me. All right, so that's what subscribe means. So anything that's connected to this MQTT broker, it can be an IoT device, it might be a cloud, it can be the client who's waiting for something, anything. Okay, they can subscribe to the subjects that the publishers are publishing. Okay, this one's subject might be let's say my server, and what did temp at home. All right. subscribe and what do you call topics, right? Let's say I need to know whenever there's news on Tempat Home. Okay, we say this server has asked subscribe to Tempat Home. All right. So whenever the MQTT broker knows this. Okay, he has subscribed to this. Okay, he has subscribed to this topic. MQTT broker knows that. Okay, so whenever MQTT broker receives a message that has the temp at home, he forwards that packet and that packet only to this guy. Okay, so the other topics it won't send if this one hasn't subscribed. Okay, this was basically everything. Okay, this might be a database, this might be a cloud, this might be another IoT device, this might be anything. MQTT broker does is whenever there is a message, it will send to those who have subscribed to it. So this is what it is, right? So the subscriber might be AWS web server or GCP Google Cloud platform or Microsoft Azure, anything. All right. So basically, I believe you got the idea of MQTT, how this works and publish a subscribe model. That means these guys publish it. If there are subscribers, broker will send those messages to them, not other messages. Okay. So and this actually uses this MQTT uses Tcpip protocol. That's why I mentioned it. Tcpip protocol. Okay. Let me share this again. All right. So there comes the ready-made Iot solutions. We have learned about theories. All right. So, and I have said that you don't have to implement those things manually, but if you want to implement something manually, you can definitely do that. Okay. You just have to have some server in the cloud. All right. It might be a VPS. VPS is a virtual private server, or basically a computer in the internet. Okay, you can get one from my favorite is Linode, because it sometimes use cloud services for various things. So the I believe Linode is the cheapest one out there. So you can basically deploy a decent I mean really decent one for like let me share CPU, $5 a month. Okay, it's like what, 1,000 rupees a month. We usually waste more money than that for things we don't use, right? If we want to deploy an IoT, we can definitely do that. I will show you some things. I have some projects that I have participated in. I might be able to show you some things. Okay, so basically you can do this, click this and deploy a completely US web server. Okay, so and you can use that and implement inside that computer. You're on MQTT broker. You want to learn how the MQTT works? No problem. Go there. Maybe spin up a text editor. If you are using now, I'm on my server. Okay, if you want to develop a MQTT server, just do it. Okay, just use Python. I believe that's the easiest one, Python, and just write the program, run it there, and you can basically test it even on the web server. Okay, because you can see. So if I would go to that website, you will see there's a web page in there. Okay, all right. So it will just show the directories in my website server, but you can easily deploy something, test it, and if you don't want this, destroy it. Okay, it's that easy to, even if you want to do something manually. But if you are not willing to take that extra step, there are solutions. Okay, so basically every new every main cloud service provider like Google, okay, Google has its own it has its own I believe Mqtt Broker. Okay, yeah, yes, I believe you can see PubSub. That is definitely with the Mqtt. Okay, so you can just go there, deploy a machine. I believe there is a little bit of a learning curve. I believe I promised the organizing committee that I will showcase one, but sorry about this. I see the time is running out, so I have to wrap this up quickly. So Google is one of them, and since you are all students, I believe you can get Google Cloud. You can get $200 of free credits from Google Cloud for your AC.lk accounts, because I believe all of you have GitHub education package with you, right? Education pack. This is something like almost everyone gets. You know, they are enrolled into a course, right? So there's this Azure $100 credit for a year. Okay, Azure has this for an year, so you have to be careful. If you have exceeded this amount, you will have to pay from your own debit card or credit card. So since we are Azure IoT Cloud, okay, so Microsoft actually has a way of complicating some things that are really simple. I'm not criticizing them, that's just how I feel about them, but nevertheless they have Azure IoT. From my experience, this might be a little bit of a long way to develop and implement something in Azure Cloud, because there are a couple of more steps. But I believe you have got this IoT, Azure credits also. So just go there and try spinning something up. All right, there's no harm. We are all here to learn. All right, there's Azure IoT, and if you are willing, there's AWS Cloud. And if I say IoT, there's definitely an IoT site. Okay, what this IoT service means is it has a very sophisticated MQTT broker, and also it has methods to store, collect data from your IoT devices really fast, really easily. Okay, so there's that. Or you can basically use something like Linode or DigitalOcean and create a personal VPS. Try some things. You can learn Linux. You can deploy your own VPN even, and you can do anything. Okay, so this is for those who like to like get their hands dirty and play. Okay, but if you are willing to deploy something in the cloud and work with it very easily, these things are the way to go. Okay, Microsoft Azure and AWS or Google IoT Core, any one of those things. So you can try all three. Okay, it's the experience you will gather. Okay, so I will really rush through those things because I believe I only have 2 hours. Okay, user interfaces. So we have this term human device interfacing. Okay, so we are human, those are machines, they communicate in ones and zeros, we communicate in our languages. Okay, we must have a way to communicate with our IoT device, and we don't have to be a programmer or a tech geek to understand what the device is saying, right? Because if it was, only the people with IT experience or technical experience will use the smartphone. But that's not the case, right? Because we have a strong HDI or HMI. We call this human device interfacing. That basically means how we have to communicate with those things between an interface. Okay, between an interface like this Zoom platform for us to communicate, like our really simple dial-up page in our smartphone to make a call. So we need to make something like that when we are implementing an IoT device, right? Like that web page to turn off on and off our lights. So one thing, one very basic platform that we have is Node-RED. Okay, so Node-RED is basically you don't even have to know to code to deploy this. Okay, so the Node term comes from this. You might have heard the Node.js framework that is used to develop websites. So it is used, made from that. So if I would just spin up my local Node-RED, it is a drag and drop interface, and we basically we don't use this for Arduinos and such, but we rather use this for Raspberry Pis. Okay, Raspberry Pis or something like that. So I'm just going to show you this. So we have those blocks, code blocks here. So we can do some flowchart stuff, because this is basically a really big flowchart. Okay, so get one, and if you have to check something or send a MQTT signal, get this no MQTT outright. We have to send this data to Mqtt Broker. You can do this just like that, and just add MQTT. Okay, you are done, and it will do just fine. Okay, so I believe I haven't set up my MQTT Broker. I just did, and we can inject some numbers, inject some values, and see how the system works. And we can actually take some sensor data in from this. Okay, we just have to actually connect those sensors and tell them I'm using this one for this and this one for this. likewise. Okay, we just have to make a flowchart. Okay, by flowchart means the right node on the right, there's a connection to the right. That means it sends something out. Okay, the connection on the left means it is taking something in. Sorry, it is taking something in, and we can basically do our whole program here. Okay, this is very famous with engineering students. I know there are some of my friends who are doing a really big project. I cannot say what it is, but they are doing a really sensitive work with really expensive equipments using this noded. Okay, so basically we can write a whole program here, and also we can create an interface from this. Okay, we can create something like an HTML and attach that, so the we can view that in web browser and all. Okay, we can do anything really fast, and it's this is a free software. Anyone can download and install. I recommend it. You do this in a Raspberry Pi. Okay, not in your local computer, in a Raspberry Pi. So you can actually connect some sensors and try this. Okay, all right. So that is one thing, and the other one is I don't believe I can show that to you. So whenever you are using IoT, you know you sometimes have to use a mobile app, right? So for that there is this MIT App Inventor. Okay, there's this MIT App Inventor software that's as the name implies developed by MIT, that can like in minutes. Oh no, you can I couldn't get it to work last time. So basically you can just go there and drag and drop some things, maybe connect a sensor, get data from a sensor, anything. And it is also based on those you might have worked with Scratch. You see, you can actually program it using just dragging and dropping those blocks. Okay, so you don't have to know programming to do something like this. And this is actually a app that I have designed to do you remember that first example that I took about remote monitoring pulse oximeter? So we have done that in the past, and this is the app I used to just spun up a mobile application in minutes. Okay, you can put a button, you can do this, you can say whenever I click this, send a request over this, and turn on my light. Okay, so you can basically do this, and you can build an application APK and install it in your Android phone, and you're good to go. Okay, so that's that in UI. And about security, so I only have a couple of minutes. So why do we need security in IoT? So basically, if we are using a computer, we know that there are hackers out there, there are viruses out there, there are many things that we can get our privacy violated. So we know we have to use something to protect ourselves. Okay, so that is the same thing with IoT. But the thing is, we are connecting a device to the internet, but we are not securing it or anything, right? We are just writing some Arduino codes or codes in C, maybe Python, and we are spinning something up. We are connecting it to the internet, just like that. And we know that our operating systems have hundreds of gigabytes of programs that actually some of them are designed for security itself, okay, to stop running the viruses and anything. So you can see from this graph, this is real one. We can see we have at least 5 times, so 6 times of bigger number of devices than our whole population. Okay, this is just 2020. Okay, from now I believe this is at least 10 times. Okay, so there are more devices connected to internet each day, and we have to be prepared to take actions. We have to take security into our equation. Okay, so the main thing I have to highlight is, first thing is healthcare. We might be designing our IoT devices to maybe monitor a patient. Okay, so that is really critical. If a hacker got into that, if a virus broke that, and we are putting our trust in this what do you call this this electronic device to take care of our patient, and that is not responding, that's a really critical thing, right? So it's just the same thing like in banking, money could be stolen. In agriculture, the whole field could be dead, anything. Okay, so internet and security is something that doesn't go in hand to hand. Okay, so whenever we are designing an IoT device, we have to worry about these things. Okay, so for that, so let's just take healthcare, because that's the most critical thing, and I believe some of you will be designing something, you have some ideas. So there is this HIPAA, health insurance. This is a something that is bare minimum. This is a, I say, regulation. It's not a rule, it's not a law, it's a regulation that anyone who's developing something, something a software, maybe hardware related to health, should follow. Okay, there's a privacy rule, there's a security rule, there's some rules in maintaining patients' data, like you cannot ever transfer something like patient's name and health details, maybe name and the what call it, the maybe their drugs they are taking in a one place. Okay, because they cannot be used to make a profile against a patient. These are really critical, and we have to make sure that data that's being transferring are not tampered with. Okay, so a middleman cannot change the data and send it, so the system wouldn't notice. These are really important things that you have to follow. Do and take a note of these HIPAA regulations. If you are ever in the process of developing a medical app, IoT device, make sure to check this out and at least try to understand what that is. Okay, so you know what you are dealing with. And there's this information security ISO 27001. So this is rating that is given to softwares and IoT devices that follows the information security standards. Okay, so this is a little bit of points for some points for anyone who's developing an IoT. So first thing is encrypt your data. So every time I've done something, I'm using clear text. Okay, every message goes in just plain text. You cannot do this. I'm saying don't do this. Okay, don't do this. And whenever you do this, encrypt data. Okay, whenever some data leaves your IoT device, make sure it is encrypted. You don't have to learn about encryption. You can just Google some encryption algorithm, something AES, and implement it. There are libraries, there are many things. You don't have to learn more things. Okay, so avoid sharing private data, even it is encrypted, whenever it is not absolutely necessary. Okay, and I am not going to talk about this sanity checks, but if you are receiving something into your IoT device, make sure you check from byte to byte that it doesn't contain anything that is not required. Okay, if you are asking for numbers, you just make sure you are just receiving numbers. Okay, you can do this with an if statement or a filter or a replace string, anything. Okay, anything that doesn't obey what you are asking for. Okay, if you would go to the internet and search for some okay cross-site scripting or anything, you will see how easy it is to break some system using an input. Okay, and okay, so these are a little bit of things that if you are not, if you are when you are already in the IoT scene. Okay, sorry. Okay, so first thing is make sure they are on a separate network. Okay, that means uh, make sure they are on a subnet. Okay, if you know networking, the subnet is something that can prevent something like even if the some virus or hacker got into a IoT network, it won't affect your personal network. Okay? You can separate those things, so at least those IoT devices will be affected, not your personal data. Okay, so and also catalog and track all the IoT devices. So make sure you track everything and what is happening to them at all times. Okay, and whenever you are developing something, make sure everyone knows these things. Okay, and if you are using a ready-made equipment, and if you are using something like that, there will always be a cheaper version of that that has the same functionalities. Okay, so make sure whenever you encounter something like that, think twice, maybe thrice. Okay, those cheaper versions comes with some what do you say compromises. Okay, and there are always privacy compliance policies and government regulations. Don't go over there. Okay, so if something happens, you will be held responsible. Okay, there are GDPR and everything that governs the whole internet, and also there are some things that our own government puts. Okay, so make sure you will give your own attention to that. Okay, so this is me. We have come to the end of the presentation here. So this is me. You can send me an email if you like. I will put my email also. If you have any questions or if you are developing something related to IoT and you need any support, please don't hesitate to send an email. So I'm a computer science undergraduate from University of Peradeniya, and okay, so there's that, and thank you. I believe you learned something and you learned something new. So if you have, then my work is done. So thank you and good night.
Thank you, Mr. Supuladri Singha. Now we will be proceeding with the Q&A session. If you do have any questions related to today's session, you can use the chat box to clarify them. Our speaker will clear them out for you.
Recording in progress.
Okay, seems like there are no questions. So before we move on behalf of the Electronic Robotics and Innovation Club of General Sir John Kotelawala Defence University, I would like to take this opportunity to thank our distinguished speaker, Mr. Supul Edirisinghe. Thank you for the knowledge and experiences shared with us today and to educate our audience on this important topic. A heartfelt thank you for taking your time to be with us here today, and it's a huge honor to have your presence here. So, Mr. Supul, please accept this digital token of appreciation.
Thank you. Thank you for the opportunity.
Thank you. And before we wrap up the IoT session, I invite the Secretary of ERIC KDU, Ehan Kodituaku, to deliver the vote of thanks.
Okay, am I audible, guys?
Yeah, you're audible.
Okay. Good evening, guys. Our guest speaker, ladies and gentlemen. On behalf of Electronic Robotics and Innovation Club of General Sir John Kotelawala Defence University, and on my behalf, I would like to extend my heartfelt gratitude for the guest speaker of today's event, Mr. Supul Edirisinghe, for gracing this event. Thank you, Mr. Supul, for spending your valuable time in educating us. I owe special gratitude to our mentors for the guidance and encouragement given to us. A big thank goes to all the participants, including both the officer cadets and day scholars from the faculties of engineering and computing who witnessed the IoT session too. Also, my appreciation goes to the team members of ERIC KDU who work towards the success of the IoT series continuously, especially under the COVID circumstances that KDU is undergoing right now. Next, I extend my thanks to all who did support us in another ways. If it wasn't for you, this wouldn't have been a reality. Thank you very much.